Okay, question number 1 says Kathleen rolled a number cube that has sides labeled 1 through 6. So there's 6 sides. And she said the probability she'd get a 2 or a 4. So there's 2 chances out of 6, which should simplify to 1 over 3, which is why B would be the correct answer for number 1. In number 2, a bag contains 10 red marbles, 15 green marbles, and 15 blue marbles. How many marbles are all together? There are 40 marbles altogether. And it said, if Deshaun draws a marble from the bag, what is the probability that it is a red marble? Well, of the 40, there are 10 red. And 10 over 40 reduces to 1 over 4, which is why A should be the correct answer for number 2. Everybody good with 1 and 2? Number 3, Kendra flips a coin 3 times. What is the probability she'll flip a tail all 3 times? The probability the first time is 1 out of 2. The probability on the second coin would still be 1 out of 2. The probability on the third coin is still 1 out of 2. Right? And obviously 1 times 1 times 1 is 2 times 2 times 2. Which is why the probability is 1 out of 8. Remember that when you have a compound event, more than one thing happening, you can multiply those probabilities together. The probability that John receives junk mail is 11%. 11% as a decimal is 0.11. If he receives 94 pieces of mail in a week, you'd take that 94 times 0.11. This actually gives you, was it 10.34 when you multiply it out? Which is why B is the correct answer. Everybody good for 3 and 4? Number 5. Gene made a 2-digit code. The first digit is odd. How many possible codes can he choose from? Well, since he's making a 2-digit code, we have the numbers 0 through 9. In other words, there's a total of 10 numbers to pick from. If the first digit is odd, how many of those 10 numbers are odd? 5 of them. So there's 5 possibilities for the first one. It could, but the first digit itself is going to be between what? 0 and 9. It could be a 9, right? It could be a 7. It could be a 5. It could be a 3, and it could be a 1. There's 5 possibilities. On the second number, how many possibilities are there? 10. And this is really, if you thought about any particular number, this is kind of the same thing as figuring the probability of getting maybe 22 as a code. Well, it'd be a 1 in 5 chance or a 1 in 10 chance. So this would tell me, the denominator tells me how many overall possibilities there are. What is 5 times 10? 50. There are 50 possibilities of combinations. Much easier to do that way than it would be to sit down and try to draw a table out. How many people want to create a table with 50 items in it? I don't. So it's easier to learn how to predict how many possible codes there are, thinking of it in terms of probabilities, than it is to sit there and draw out a table. Let's see, we got 3 pairs of pants and 4 shirts. Same concept as number 5. If I chose a particular pair of pants, it'd be a 1 in 3 chance, right? If I chose a particular shirt, it would be a 1 in 4 chance. Really, all I'm interested in is what? The denominator, because it'll tell me how many possibilities overall there are. And what is 3 times 4? 12. That's why B is the correct answer for number 6. Everybody good with 5 and 6? Number 7, a classroom has 7 blue chairs, 5 green, 18 red, 9 yellow. If a chair is selected at random, which color is most likely to be chosen? Rather than figuring probabilities, this is one where you can just look at it. The one that has the most is most likely to be chosen. The answer for this is C, red. If we're spinning a spinner, it has yellow, green, blue, and red on it. Yellow, green, blue, red. What's the probability that they're going to spin orange? 0. There is no orange on the spinner. It's not possible. Everybody good for 7 and 8? Number 9, the experimental probability that Daria will win a game is 3 out of 8. If she plays 80 times, how many times can she expect to win? Well, if I take the 3 out of 8, the experimental probability, times the number of times she's going to do something, it will allow me to predict how many times she can expect to win. How many times does 8 go into 80? 3 times 10? 30. She can expect to win 30 times. Jackson flipped a coin 10 times. He flipped heads 4 times and tails 6 times. How many times did he flip the coin? 10. What is the experimental probability that Jackson will flip a heads on the next flip? The experimental probability was 4 out of 10, which is the same as 2 over 5. This is one of those questions where I would say, even if you know what the theoretical probability is, they're saying, what is the experimental probability that he's going to get a heads? And you have to use that probability instead of the theoretical probability, which is why the correct answer for number 10 is B, instead of what? Instead of C. Out of curiosity, how many had C for an answer in this class? Okay. It's what I would have expected to see happen. So be careful. If they're talking about experimental probability, that you use the experimental probability even if you know theoretically that 2/5 shouldn't be the case. Everybody good with 9 and 10? Number 11. Melissa rolls 2 number cubes. They're labeled from 1 to 6. This is a compound event. On each number cube, there are 6 sides. What is the probability that both number cubes will show a 1? What's the probability of getting a 1 on the first one? 1 out of 6. How about on the second one? 1 out of 6. And we simply multiply these 2 events together, so it would be 1 out of 36. So D is the correct answer. A sandwich shop offers 3 types of bread, 4 types of meat. If they offer 3 types of bread and 4 types of meat. This would technically be the denominator of something if we were doing probability. And what is 3 times 4? There's 12 possible selections interchanging those. And again, you could create a table and figure it out, but isn't it easier just to multiply the numbers together? The probability that Doreen wins a game, the chance is 1 out of 3. If she plays 300 games, this too is just a multiplication problem. 3 goes into 300 100 times, so she should expect to win 100 times. Questions on 12 or 13? (14) and 15. Tyler recorded the hair color and eye color of the students walking in the hallway outside her homeroom. What is the experimental probability that the student she sees will have blue eyes? So, this is the eye color here. If I add this up, 5 and 14 is 19. 9 and 12 is 21. How many total people walked by? 40. Okay. Yep. Eye color is here. So brown eye color that had brown hair, there was 9 of them. Blue eye color that had brown hair, there was 5. Brown eye color, blonde hair, 12. But here they're only looking at what? They want to know how many people have what? Blue eyes. So the only thing I was concerned with was what? Eye color. By the way, if I totaled up my hair color, 9 and 5 is what? 14. 12 and 14 is 26. When I add those together, what should it give me? 40. Otherwise, they've got somebody with no hair or no eyes. Right? The two should be the same when you total them up. So, here they said the probability of blue eyes. Well, my denominator should be 40. And they said blue eyes. Well, since the hair color doesn't matter, I've got to have the total of the blue eyes, which is 19. So, 19 out of 40 would be my probability that the next person would have blue eyes. And Dylan, since the table was confusing to you, can you tell me the probability that somebody would have brown hair and brown eyes? 9 out of 40. Can you tell me the probability that somebody would have blonde hair? Which I put off to the side. 26 out of 40. Table makes sense now? Okay. Number 15. Brianna rolls a number cube that has 1 through 6 and flips a coin. So, it's possible that she would get a 1 with the heads, a 2 with the heads, a 3 with the heads, a 4 with the heads, a 5 with the heads, or a 6 with the heads. It's also possible that she'd get a 1 with a tails, 2 with a tails, 3 with the tails, 4 with the tails, 5 with the tails, and 6 with a tails. By the way, how many things should be in my list, and how could I find out? There should be 12 things. There was 6 possibilities on the number cube, 2 possibilities on the coin, so there should be 12 things in my list, and there is. Questions on 14 or 15? Number 16. Maria randomly selects a number from the list that's shown. What's the probability that she selects an even number?
Is 90 an even number?
Yes. If it ends in 0, it's an even number. It's divisible by 2. Okay? So, all of these happen to be even. There was 1, 2, 3, 4, 5 possibilities. 5 out of 5 is equal to 1. Or you could say it was 100% chance that she would select an even number. What's the probability that she'd select an odd one? 0. 90 is not an odd number. That's right, it is divisible by 5. But it's also divisible by what? It's not asking if it's divisible by an odd number. Is it even or is it odd? And it is definitely what? Even. Okay? Number 17. Kelly conducted an experiment. In each trial, she flipped a coin and rolled the number cube. And the results is shown above. What is the experimental probability that her next flip will be tails? Since they're not talking about the number itself, they're only looking at the heads or tails. There were 5 trials, and 1, 2, 3 of those trials had tails on it. Out of curiosity, how many people had 1 out of 2 for this one? Okay. Again, this goes back to experimental versus theoretical. Theoretical is 1 out of 2. What's the experimental probability that you'll get a tails? 3 out of 5. You have to use the data if they're asking about experimental probability. Everybody good with 17? What are you confused about? Let's talk about the number side then. Since I already did let's talk about the number side. Let's say I said the experimental probability of getting a 3. Okay? Theoretically, what's the probability that I'd get a 3 on a number cube? 1 out of 6. I'm not interested in that. I'm interested in the experiment. There was 5 trials. And 1, 2 of those 5 were 3s. What's the experimental probability then that I'll roll a 3? 2 out of 5. Got it? Make sense? So when I looked at tails, there was 1, 2, 3 tails out of the 5 trials. So there's 3 out of 5 chances that I'm going to get a tails on the next try. Number 18. Colleen wrote each letter A through Z on a separate piece of paper and put them in a hat. How many letters are in the alphabet? 26 letters in the alphabet. Okay? A, E, I, O, or U. There's 1, 2, 3, 4, 5 of them. So the probability that she's going to get a vowel would be 5 out of 26. If you planted a garden with equal number of roses, daffodils, and tulips. So there's roses, daffodils, and tulips. If she selects at random, what is the probability that it will be a lily? She didn't plant lilies. She's not going to get a lily, is she?
If she's crazy woman, she might see a lily. I want to go get my lily.
Everybody good with the review? What should you do tonight?
Study. I like to study.